Good morning everyone. Today we would like to present our topic on full system renewable energy sources with a focus on future developments and innovations. Before we begin, let me introduce my group members. First we have Nur Shahdina binti Shamsul, followed by Fateh Norliana binti Sabu and Nur Eliani Sofia binti Basharuddin. And I'm Nur Anis Akila binti Rosli. For today's presentation, each of us will be covering different parts of the topics. So, without further delay, let's begin our presentations.
So, what is a full system? Full system, it is an end-to-end infrastructure that captures natural resources such as solar and wind, then convert them to electricity, store the surplus and distribute it to the user. The big challenge that we are facing is that renewable energy is variable and decentralized, such as the sunset and wind speed change. However, there is the solution, which is we must rely on the scientific instrumentation, such as sensor, controller, and data tools, to keep the power grid stable, safe, and efficient. And these are one of the relevant scientific instrumentation and application concept, which is data acquisitions. By solar instrumentation, we have pyrometer, where it measures solar irradiance to calculate maximum expected efficiency. While for temperature sensor, we monitor panel heat in case solar cells lose efficiency as they get too hot. While for wind instrumentation, we have anemometer and wind vane, with each it measures wind speed and direction to automatically turn the turbine and adjust blade angle. As for string gauge, it monitors physical stress and structural fatigue on the blades. Next is power conversion and electronic, where we have maximum power point tracking, where a microcontrolled electronic system that samples the solar or wind output. It continuously adjusts the electrical load to extract the absolute maximum power possible along the generator voltage curve. As for inverter instrumentation, where it converts direct current from panel or battery into alternating current for the grid, where it uses a precise transformer to match the grid exact frequency and minimize electrical noise. And third is energy storage and diagnostics, where we use battery management system, a specialized instrument cluster that monitors battery health, such as we have state of charge, where it tracks how much energy is left by using whole counting to measure current over time. Second is state of health, where it uses electrical impedance to check for battery degradation and wear. And lastly is thermal safety, where it monitors individual cell temperature to prevent overheating and fires. It's automation and grid control, where we have programmable logic controller, local microprocessor that take instant sensor data and execute safety command. Example is where one is at storm speed, it will trigger emergency mechanical brakes. And second is SCADA system, where it's supervisory software that collect data from the entire plant for the high-level monitoring. Lastly is a pressure measurement unit, where it is an advanced grid instrument that sample electrical wave up to 16 times a second using GPS timestamp. This allows the grid to instantly inject battery power if a cloud suddenly blocks the sun.
Today I want to talk to you about a new system we are implementing called SCADA. SCADA is an acronym that stands for Supervisory Control and Data Acquisition. And it is a system that utilities use to remotely monitor and control equipment across the electric grid in real time. It also gives us alarms and outage conditions. That way we can respond faster and make smarter decisions. So not only does SCADA provide protection for our customers, but it also provides protection for our linemen. It also helps our linemen by giving dispatchers real-time visibility and remote control on field equipment before and during switching operations, so crews aren't relying on assumptions or delayed information. SCADA reduces the risk of accidental backfeed, unexpected re-energization, and switching errors. Fiber has improved our substations considerably. Before we relied on satellites and cell phone modems and those just weren't reliable enough. It also just reduces the outage time so that everybody goes home safe, everybody gets their power on quicker, and we can move on to the next outage. With the fiber connecting the electrical grid across our system, we are now able to begin implementing the SCADA system. SCADA talks to us in real time and can detect faulty electrical current, which in turn reduces the outage response and restoration time.
Hello, for this part, I will explain on the details exploration of the hybrid renewable energy system. This system consists of several main components that work together to generate and manage electricity. First, solar panel capture sunlight and convert it into electrical energy. At the same time, wind turbines generate electricity by converting wind energy into mechanical motion and then into electrical power. The electricity produced from both sources is then managed by a controller. The controller is important because it regulates the power flow to ensure the system operates safely and efficient. It also helps to balance the energy supply from both solar and wind sources. Let's look at how energy flow through the system. The process begins when solar panel and wind turbine generate electricity. The generated energy is then sent to the controller, which manage and regulate the power flow. If the energy produced is not immediately needed, the excess energy is stored in batteries. When electricity is required, the inverter converts the stored DC electricity into AC electricity. Finally, the electricity is distributed. Systems are used because they provide a more reliable source of energy. Solar energy is only available during the daytime and depends on sunlight intensity. Wind energy, on the other hand, depends on the weather and wind condition. By combining the both energy sources, the system can generate electricity more consistently. The batteries also help maintain a continuous power supply during period of low energy generation. As a result, the hybrid system can continue operating even when one energy source is unavailable.
Topic 3. Renewable energy sources. Renewable energy sources are essential for reducing our dependence on fossil fuels and combating climate change. Unlike coal, oil, and gas, renewable energy comes from natural resources that are constantly replenished, such as sunlight, wind, and water. These sources produce electricity without releasing harmful greenhouse gases, making them more environmentally friendly. A solar energy, generated through solar panels, is increasingly popular because it can be used in homes, businesses, and even large power plants. Wind energy is another fast-growing option, with turbines producing clean electricity in many countries. Hydropower, the oldest renewable source, continues to provide a significant share of global energy. In addition, emerging technologies such as geothermal and tidal power show great potential. However, renewable energy faces challenges, including high initial costs, technological limitations, and dependence on weather conditions. For example, solar panels do not generate electricity at night, and wind turbines need steady winds. Governments can help by investing in infrastructure, offering subsidies, and supporting research. Overall, renewable energy is a key solution to global energy problems. Transitioning to cleaner energy sources not only protects the environment, but also creates new jobs and supports sustainable development.
Next, let's look at some real-world examples of renewable energy. First, Badla Solar Park in India is one of the world's largest solar power plants, which generates large amounts of electricity from sunlight. Second, Iceland uses geothermal energy from underground heat to produce electricity and heating, providing a reliable renewable energy source. Third, the Hornsea Wind Farm in the United Kingdom is a large offshore wind farm that supplies clean electricity to millions of homes. Scientific instruments such as solar sensors, anemometers, and temperature sensors help monitor and improve the performance of this renewable energy system.
The Badla Solar Park, situated in the Rajasthan Desert in India, is the world's largest solar farm. Spanning over 14,000 acres, it began generating power in 2018. The park's solar panels produce 2,245 megawatts, enough to power over 1 million homes. making it the world's biggest solar farm.
Meet Hornsea 2, the largest offshore wind farm on Earth. It's 89 kilometers off the coast of Yorkshire, in the North Sea, with 165 Siemens Gamesa turbines, each nearly 200 meters tall. It powers over 1.4 million homes with clean electricity. And that's just part of the plan. Future phases could power 5 million homes.
Renewable energy offers many benefits. It reduces greenhouse gas emissions, uses naturally replenished resources, improves energy security, creates jobs, and supports sustainable development. However, there are also challenges. The initial installation costs can be high. Solar and wind energy depend on weather conditions. Energy storage systems are often needed. Large projects require significant land, and grid integration can be complex. Despite these challenges, renewable energy remains an important solution for a cleaner and more sustainable future.
Now, I will present about future developments and innovations in renewable energy. First, let's look at next generation solar technology. New innovations like perovskite solar cells are being developed because they are cheaper and more efficient compared to traditional silicon panels. In addition, transparent solar panels can be installed on windows and buildings, allowing us to generate energy without using extra space. There are also floating solar farms which are placed on water to save land space and improve efficiency. Lastly, bifacial solar panels can absorb sunlight from both sides, which increase the total energy output. Next, for advanced wind energy system, floating offshore wind turbines can now be installed in deep ocean areas which wind is stronger. Vertical axis turbines are more suitable for urban area because they are lighter and more compact. Bladeless wind turbines are also being developed, which are safer and require less maintenance. And finally, airborne wind energy systems such as kites or drones can capture stronger winds at higher altitudes, making them more efficient. Next, we move on to energy storage breakthrough. Energy storage is important because renewable energy sources like solar and wind are not always available. Solid-state batteries are a new development that is safer and has a longer lifespan compared to traditional batteries. Grid-scale storage systems are also used to store excess energy so it can be used later when needed. Another innovation is green hydrogen, which stores renewable energy and can be also used as a clean fuel. Flow batteries are also being developed for large-scale and long-duration energy storage. Now, let's look at emerging renewable sources. Tidal and wave energy are very reliable because ocean movements are predictable. Enhanced geothermal systems allow us to generate energy from deeper heat inside the earth. Biomass innovations help convert waste material into electricity and biofuel. Lastly, ocean thermal energy conversion or OTEC use temperature differences in seawater to produce energy. Moving on to smart energy systems and artificial intelligence. Smart grids are used to distribute electricity more efficiently by using real-time data. AI and machine learning can predict energy demand and help optimize energy usage. IoT monitoring systems are also important because they track the performances of renewable energy systems. Virtual power plants combine multiple energy sources into one system, making energy distributions more stable and efficient. Finally, let's look at future trends and innovations. Space-based solar power is an advanced idea where solar energy is collected in space and transmitted back to Earth. Wireless energy transfer could allow devices to be powered without cables in the future. Energy harvesting technology can generate energy from everyday sources like movement, heat, and light. Carbon capture integration is also important because it It helps reduce emissions while producing energy. In conclusion, renewable energy is becoming more efficient, more affordable and smarter. Future energy system will be more integrated, sustainable and driven by advanced technology. Therefore, innovations play a very important role in achieving a clean and sustainable energy
A
future.
roof that protects and generates energy for an entire building. Let me introduce you to the EBS Power, a revolutionary energy solution that combines the power of the sun and wind to generate 6 times more energy than conventional solar panels. The secret behind this innovative system lies in the clever combination of solar panels and wind turbines. These solar panels are mounted on a metal structure that extends about a meter from the building, and this not only optimizes the space available for the panels but also allows the wind to flow smoothly underneath the structure. Wind turbines are strategically positioned just below the structure, capturing the wind energy as it passes. But here is the real brilliance. As the wind passes through these turbines, it also acts as a natural cooling for the solar panels. This increases the panel's efficiency by 15%, making the entire system even more powerful. Now, imagine the positive impact a system like this could have in our
To
city.
conclude, a hybrid renewable energy system combines both solar and wind energy to provide a more reliable and consistent source of electricity. The system consists of several important components, including solar panel, wind turbine, batteries, inverters, and controllers. These components work together to generate, store, and distribute electrical energy efficiently. Battery storage plays a crucial role in maintaining a continuous power supply, especially during periods when sunlight or wind resources are limited. By integrating multiple renewable energy sources, the system can achieve better stability, improve efficiency, and more dependable energy supply compared to single-source system. Overall, hybrid renewable energy system contribute to sustainable development by reducing dependence on fossil fuel, lowering carbon emission, and supporting a cleaner and greener future.